Hi everybody, welcome to the session, and this is called a mini technology time machine panel session. The topic is on immersive future, tying in with the Consumer Electronics Show in terms of VR, AR, MR, and any other type of reality topic. And I've invited several experts here in the field to provide a diverse perspective, because they all represent different areas of technology and innovations, to really comment on, based on their experiences, what they're working on, to provide their observations and maybe provide a tie-in what the future might look like. And by the way, I'm Kathy Grice, Senior Program Director in IEEE, and I wanted to acknowledge too Tom Coughlin, and Doug Zuckerman. Doug could not be here. We organized this panel. First off, though, I wanted to highlight and acknowledge IEEE Future Directions. We're a small team where we look at various technologies, both current, emerging, and future technologies, in terms of where IEEE might provide energy and thought leadership in developing what I call sort of a startup area. These usually run about 3 to 5 years, where you think about it, we're kind of a startup. We provide VC capital into it and get it started, identify areas of opportunities for perhaps leveraging existing conferences, new conferences, educational opportunities, standards development, education, and publications. You'll see on the left, working your way to the right, left are the ones that were just starting up, for example, 5G. Brain's pretty cool, and Conor here I'll introduce in a moment, but that's really looking at everything that involves with the brain. The digital senses, we're going to kind of reinvent that and call it digital reality. Covers, AR, VR, MR. Blockchain is a fairly new one. I know that at CES here, we've talked a lot about blockchain, and particularly the introduction of Bitcoin a few years ago. But I feel like this area is just starting to get exciting, but also a lot of sort of sensitivities around there too. Huge impact in terms of our day-to-day lives. And then the one below is symbiotic autonomous systems, in terms of emerge of robotics and autonomous systems. And then we've got rebooting computing. If you think about, this thing about, gee, are we at the limits of Moore's law in terms of semiconductors? And so we're looking at reinventing and predicting new hardware and software architectures beyond Moore's law. And then the ones on the right, pretty much you're very familiar, like big data, cybersecurity, cloud computing, Internet of Things. These are ones that we had worked on, got started, and they're ingrained in the IEEE infrastructure. Check out for more information. On the bottom there's URL, IEEE.org/future directions. And as I said, this is a mini technology time machine. It gives you a little bit of a taste, a sample of what our 2-day event will happen on October 31st, November 1st in San Diego at the Hilton Bay Resort. It's right on the bay there. And check out more information, ttm.ieee.org, and you'll see on the far right is one of our flyers, and you can take a copy to go with you. There's one on table and elsewhere. We've got one confirmed keynote speaker, and that's Saval Oz. She's pretty cool, and she's also known as the brother of Dr. Oz too. But she stands out on her own, and I encourage you to consider to come to that. Okay, our panelists, I'll quickly just introduce, raise your hand, Tom, President of Coughlin Associates. Yeah. Nick Knapp there, Xmark Labs. Conor Russomanno, director at Meta. And I believe their bios and everything are available, so you can provide your introduction later to more detail. And then last but not least, Tao Zhang from Cisco. All right. Okay, and what I'll do is invite Conor to come up.
Let's see how swift we can make this transition.
Do you need the Bluetooth?
No, we should be okay, I think, as long as this works. How's everybody doing today? And all right? All right. I hope you drank coffee at lunch. All right, how are we doing? Boom. Let's go full screen. All right. My name is Conor Russomanno. I am the Director of Advanced Interfaces at Meta, which is an augmented reality company that focuses on both hardware and software. But I also co-founded a company called OpenBCI, which is a biosensing open source hardware and software company that specializes in EEG, which is a form of non-invasive brain-computer interfacing, but then also other sampling of other bioelectric signals from the body, such as heart rate variability, EMG, accelerometer data, and such. I'll go into a little bit about me, my background. So I went to Columbia Engineering for undergrad, where I studied engineering graphics, civil engineering, and engineering mechanics. Then went on to pursue an MFA at Parsons School of Design, and while there I focused on design and technology, but specifically creative coding, hardware prototyping, physical computing, and it was in my grad program that I discovered EEG and how to really just measure electricity from the body. It all kind of started, I played a number of contact sports when I was in high school and college, and I suffered a few concussions, and I think that actually was the starting point to my interest in neuroscience and brain-computer interfacing, because there were points when I was dealing with the repercussions of my concussions, and really interested in trying to figure out how to hack my own consciousness and my own physiology to kind of navigate my way through these consciousness depths that I was experiencing. So it was at that point that I started the beginnings of OpenBCI, which was, OpenBCI stands for Open Source Brain Computer Interface. So I was really interested in propagating and democratizing existing EEG technology, because it was very expensive for me at the time to do graduate level research with the tools that existed. And I'll get to the meta thing at the end. So in undergrad, this is an example of the coolest project I think I worked on in undergrad. So it was called CyberGrid, and the idea was to take architecture and civil engineering teams from different universities around the world and bring them into a virtual space with avatars to collaborate in 3D. And this was, I worked with another engineer who went on to work at Pixar as a computer engineer, but we basically built this, using Unity, we built this virtual environment where you could create an avatar, come into this virtual world similar to Second Life, and then import 3D models of buildings. And the idea, we didn't finish this by the time we graduated, but the longer term timeline was to be able to import BIM models and 4-dimensional models with timelines and construction plans into a 3D environment, and to be able to talk about this with engineers remotely around the world. So then I went on to Parsons, where I started working on physical computing, and this is the first brain-computer interface I ever built. As you can see, it's really, really nice looking. We almost went to market just with this design, and then so then in grad school, I built a series of progressively less clunky looking headsets, but I was really, really interested in looking at how do we take these subjective experiences and emotions and mental states, such as anxiety, stress, productivity, things like that. How do we add some type of discrete or objective metric to this data? And my theory was that we could use EEG and other biometric sensors and signals to begin to quantitatively understand these otherwise rather subjective emotions and feelings. So of course, my thesis, I got a lot of pushback from my advisors at that time because they thought that my project was too ambitious, which it was. But then after grad school, I co-founded this company, OpenBCI, which was kind of the continuation of my early thesis ideas. And what we did is we launched a Kickstarter campaign, and I did this with one of my professors in grad school. We launched a Kickstarter campaign for a brain-computer interface for makers. So the idea was to kind of rethink the way that this technology could be brought into education, the commercial space, et cetera. And so we designed, who here is familiar with an Arduino? Probably most of you, since we're at an IEEE conference. So what we did is we essentially built an Arduino that was kind of a high-powered biosignal acquisition system stuck onto an Arduino microcontroller. And so that became the OpenBCI PCB. You see a few prototypes of them here. And then we went on to design a 3D printable EEG headset. And so individuals ever tried it, and they're demonstrating a very easy, quick learning curve of essentially remapping the way that their muscles are controlling a computer. And so this individual was able to grab onto this little chapstick and hold onto it with a robotic arm, never having practiced before. Granted, this was muscle data, not brain data specifically, but it was still really cool to see. So here on this slide, I was going to link to OpenBCI's website just to give you a little bit more on OpenBCI, but what I'll do is I'll just come here. So this is OpenBCI, and so what we do is open source brain-computer interfaces, but the amplifiers can be used for other things, EEG, EMG, ECG, accelerometer data. And everything that we've built is open source, all the hardware and all the software design. So you can come to this is essentially the dictionary or the glossary of all designs and software ever created. And you can come in here and explore this and really kind of just pick up where we left off to move the platform of OpenBCI into your own vertical. And so all of our software licenses are MIT licensed, so you can really just do anything you want with it as long as you attribute to OpenBCI. Most of our code is on GitHub, and we have a really large community of people who create posts and have now started to, in an unsolicited way, contribute to our communal WordPress. And so it's really this exciting movement that's taking place where people are not just creating, but they're sharing what they're building, and they're kind of living the OpenBCI vision by pushing the technology forward in a transparent way. So moving on. Here's some facts about OpenBCI. So we ran 2 successful Kickstarter campaigns. Our tech has been sold and is being used in over 80 countries around the world. And actually, this year at CES, I was touring all of the booths, and there were way more EEG-based companies now that have products on the market. And I was talking to most of them, and almost all of them had an OpenBCI system that they were prototyping with over the course of the last 3 years. So that was really exciting to see. And essentially what we've done is we've taken research-grade EEG and we've made it 10 to 100 times cheaper than what existed, 5 to 10 years ago. And there are a number of other companies that are doing this well currently, but I think that we are at least leading if not leading the pack, we're very close to being the individuals that are pushing or democratizing EEG technology. And so, like I said earlier, a large online community. So recently, about 5 months ago, I joined the company Meta as the Director of Advanced Interfaces. This is our CEO, our fearless leader, Miron. And I really hope this video works because this is a funny one. So I was going to say that this is what we're doing at Meta, which is, this is this video of the evolution of a human from caveman all the way to this. And I was going to make a joke about how that's what we're doing at Meta, but not actually. Let's see. Sorry, it's freezing up a bit. Maybe it's trying to load the video. Oh, okay, moving on. So really what we're actually doing at Meta is we're trying to understand how to design the future of AR in a way that's very intuitive for your brain. So our CEO our CEO Marone studied neuroscience in undergrad, and so at the core of all of our design principles is this idea that we as humans have evolved in a 3D reality, and we should design interfaces and applications and technology that leverage hundreds of thousands of years of evolution to understand the world in a 3D space. And so we have an extensive published list of design principles about spatial design and also user UX design that account for this kind of core understanding of the way that your brain is supposed to perceive interfaces, and not the way that large corporations feel that they can grab your attention and things like that. So these are the lists. The primary one for spatial interface is to think spatially, minimize abstractions, and then this idea that you are the operating system. The computer should be based on the way that you are thinking and the way that you are perceiving your environment and the things that are most natural to you. Luckily, our CEO at Meta really kind of sees these dystopian scenarios in which we have pop-ups and ads and buttons being thrown at us at any given point in time, and we are trying to avoid that to the best of our ability as we design the future of this space. So there's a few principles: do not disturb, avoid surprises and magic tricks, and public by default. So the holographic campfire is this idea that for tens of thousands of years, humans have been coming together to sit around campfires and look at each other in the face as they experience a communal session. And we believe that AR has the ability to do this in a really profound way, because now, as opposed to looking at a two-dimensional screen, we can actually perceive and interact with 3D content while also looking at each other. And so the idea of a holographic campfire kind of embodies that. And then here's another list of our user interface guidelines, optimizing the workspace, kind of designing for productivity. And similarly, getting back to what I did in grad school, kind of trying to optimize moods and reduce negative moods and enhance positive moods. This is core to Meta's engineering and design principles as well. This video is probably not going to work, but this is our CEO talking about this concept of you being the operating system and not the other way around. Here is a nice GIF of kind of a concept of us being able to interact with a 3D model of a car in a new way, and being able to kind of perceive the 3D content, but also the idea is to be able to model and actually build 3D content in a 3D environment, as opposed to the way that we do it now, where we have a series of 2D panes and we're trying to construct a 3D object with a 2D interface. I'm going to wrap it up here, but the future of human-computer interaction, and I'll get to this more in the Q&A, is this idea of human, computer, and interface all thinking as one, as opposed to this kind of distant, separated ideas. That we believe that the operating system can have a truly fundamental idea of your emotions, the way that you're perceiving and interacting with content, and how do we leverage that using emerging sensors like eye tracking, EEG, heart rate variability, PPG. There's a huge list of sensors out there. Haptics is a big one. I think that it would be wrong of me not to mention the value of haptics in the future of augmented reality, because the sense of touch is the first sense of any living organism, and we're going to need to play that up as we really try to reduce the learning curve to interacting with the future of technology. So with that, I'll wrap up. Thank you very much, and here are my emails if you want to reach out to me, and I'll have business cards afterwards. Thank you.
Thank you very much, Conor. Very interesting. A lot of things to ponder, too, in terms of implications to humans.